Why are we diseased? Dear Lily, the world, including the human body, is full of tiny organisms. When there are either too many or too few of them, they can be harmful to humans. These include those without life, such as viruses and prions, as well as the vast array of bacteria and similar living microorganisms. Some diseases are with us all the time. Others suddenly sweep across the population. Endemic diseases, such as malaria, dysentery, leprosy, and the common cold, are present all the time. Epidemic diseases, such as influenza, measles, cholera, and plague, burst out suddenly for a few months or years, then usually subside when their hosts have been destroyed. There are four main ways in which diseases spread. There are bacterial diseases, which are carried into the body through the mouth in contaminated food and drink. The various forms of dysentery, typhoid, and cholera are examples. If we are to understand how these types of disease change over time, we need to look at human eating, drinking, and cooking patterns, and the ways in which humans and others deal with excrement. A change such as eating a new foodstuff or installing a new sewage system can alter the pattern of these diseases. Then there are vector-borne diseases, which are injected into parts of the human body by creatures like fleas, lice, mosquitoes, flies, and other insects and snails. Major diseases of this kind are plague, typhus, and malaria. These are affected by housing, clothing, footwear, and bodily hygiene. There are also diseases that spread through bodily contact. These include leprosy, venereal diseases, and various skin and eye diseases. A new one is AIDS. Finally, there are airborne diseases, viruses that travel short distances when people cough or sneeze or just breathe, such as smallpox, measles, tuberculosis, and influenza. These are very difficult to protect against, as are a number of the other diseases whose causes are little understood, such as various forms of cancer. Why do diseases become more deadly over time? Early successes in increasing human resources in the past led to denser populations in large cities and a more congested countryside. This situation would provide sufficient population density for viral infections such as influenza, smallpox, or measles to be sustained and spread. It would also lead to increased dirt and pollution of water supplies, which would raise the levels of disease such as cholera, typhoid, and dysentery. When war or famine occurred, the final death toll would be accounted for largely by the deaths from diseases afflicting a weakened population. As the population built up, cities and towns would become slaughterhouses, gobbling up immigrants who died of the diseases of crowding. Until very recently, this seemed an inevitable tendency. Human populations could reach only a certain density before automatically creating a situation where numbers were cut back by one disease or another. The rise and fall of ancient civilizations, as well as the collapse or stationary state of many European and Asiatic societies at various times in the last 1,000 years, can be accounted for by the ravages of disease. No escape from this pattern seemed possible. Did we have to wait for modern medicine? Many aspects of the history of the rise and fall of diseases up to the present are still a mystery. But one or two things are plain. There seems to have been a dramatic improvement in health in England from about the middle of the 18th century. One feature of this was the disappearance of recurring bouts of plague. By 1750, it seemed clear that both England and in Western Europe as a whole, plague had disappeared, bringing an end to constant anxiety about this horrific disease. Yet no one really knows why, after about 1665, plague suddenly vanished within about 10 years in England. The fact that bubonic plague vanished within a few years over all of Western Europe suggests that the disappearance cannot have been caused primarily by a change in the type of rat, from the black rat to the brown rat, which in any case occurred 50 years later. Nor is it possible that all over Europe there was a dramatic change within a few years in the nature of the fleas or the bacillus, in housing conditions, standards of living, clothing, or climate, or in any of the other factors usually cited. Some of these may have contributed, yet the only plausible pan-European explanation is that the periodic entry of plague through shipping from Turkey was prevented by the quarantining of ships when they arrived in West European ports. Another significant change in England was the rapid decline of malaria. It was noted that in 1700 about 1 in 20 of the London population died of the symptoms of malaria. By 1800, malaria was unknown as a cause of death in the city. The previously heavily malarial regions of East Anglia and the Kentish and Sussex marshes were no longer centres of danger. Again, we do not really know why this happened. The explanation that it was due to improved drainage, better houses, or changes in animal keeping is not convincing. All that is certain is that while southern Europe, and particularly Italy, were becoming more malarial, England in the 18th century became almost free of the disease. A third change concerned smallpox. Smallpox did not disappear in this period, and there is much argument about whether early vaccination had any positive effects. But this disease certainly began to infect and kill different people. By the 1750s, smallpox affected mainly children, and in many cases did not kill them. Why did fewer babies die? Dysentery, along with malaria, is the greatest killer in history. One of the main ways harmful microorganisms enter the human body is through the mouth, particularly in the 2 to 4 pints of liquid that every human has to absorb daily in order to stay alive. A couple of pints of liquid could contain enough dysentery bacteria to kill the inhabitants of a small city. Almost all liquids that humans drank in the past, particularly milk and water, were contaminated. People with dysentery evacuate the microorganisms in their feces. These microorganisms then pass on to hands and clothing, and in particular enter the water supply. Others then become infected. At least half the infant deaths in most societies in the past were caused by infant diarrhea, which dehydrates the body. As a population grows denser, it will pollute the water supplies with human excrement. London, a city that grew hugely in the 18th century, was a classic example, and dysentery rates should have been soaring and increased. Yet, from about the 1740s, there was a reversal of this trend. Mortality from dysentery had risen until nearly the middle of the century, and then, suddenly, it started to fall. This meant that the largest city on earth enjoyed relatively low rates of infant and adult dysentery. This was one of the greatest reversals in history. How had it been achieved? Again, we do not know for certain. All we do know is that all the conventional explanations, that it was due to improvements in medical knowledge, in hospitals, and in the treatment of disease, or to changes in the nature of bacteria, in the food supply, in public sanitation and hygiene, and in housing, are unsatisfactory. Many of these did not occur at all at this time. Those that did were not significant enough to explain the change. What did people drink? What we need to do in solving the problem of this escape from the dysentery trap is to ask what the English were drinking from the 1740s. If they had been drinking water, then a rise in dysentery, in the absence of water purification and proper sanitation, would have been the result. In fact, the majority of people did not drink water. In England, the usual drink had at that time just become tea. Tea became the staple drink of the English in the middle of the 18th century. The boiling of the water to make tea killed many of the dangerous amoeba and bacteria. Furthermore, the tea contained a substance called tannin, which are phenolics, which is one of the most powerful antibacterial agents known to man. Typhoid, cholera, and dysentery bacilli, when placed in even a cold cup of tea, will be destroyed within a few hours. By drinking tea, people wash out their mouths and stomachs, ingesting a liquid that is not only sterile because of the boiling, but also a powerful antiseptic. The Japanese, and before them for some centuries the Chinese, had benefited from this. And now the British too began to enjoy the healthful effects of tea. It was largely an accidental benefit, for tea was drunk mainly for its taste and invigorating effects. Yet the accident led to the escape from one of the apparently unavoidable death traps. Even infants drinking the phenolic-infused milk of their mothers benefited from the practice. What other reasons are there for the decline of disease? England did not suffer from any successful large-scale foreign invasions for almost 1,000 years. It did not endure totally devastating civil wars. Famine and food shortages were less severe than in most agricultural societies. The standard of living for the majority of the population was well above subsistence level. This meant that many people in England in the past, at least compared with rural workers in many civilizations, were relatively well fed, clothed and housed, and did not overstrain their bodies in manual labor. Thus, through a set of interconnected and often accidental features, the normal tendency to more sickness as population grows was temporarily avoided. This was not through a triumph of medical science or the accident of bacteriological or climatic change. It seems to have been largely a side effect of social, economic, and political institutions, which had created an unusually stable, modestly affluent, and well-regulated population. The English could still be subject to new diseases, for example, cholera and influenza, just as we are subject to AIDS today. Yet England was starting to escape from a more or less universal tendency or path. This path had always in the past meant that the efficiencies created by a larger number of people living close together in cities and small towns led to a health disaster. The modern rise in population transformed a sickly, war-ridden, famine-prone world of 500 million, that is 500 million people in the middle of the 18th century, into our present one with 12 times that number. In theory, it is possible for 12 times the mid-18th century population to live in relative peace and plenty, though perhaps only half of the world's population actually do so. This was unimaginable in 1750, yet it has happened. The first phase of this had occurred in England by 1800. The second would follow from the later 19th century, when a truer understanding of microorganisms was reached and effective treatments for many of the major killers were developed. Yet the story is far from over. The spread of many new diseases, AIDS, SARS, MRSA, the return of old ones, malaria, tuberculosis, and the growing resistance to antibiotics reveal the continuing struggle between species. Humans are predators on many other species. They are also an easy prey for microbes. There is still enormous suffering from disease. Better food, better water supplies, and better sewage systems, which could be installed throughout the world for 1/10 of the cost of current production of weapons of war, would halve the rates of many types of illness. An observer from another planet might be puzzled. As a species, we prefer to put our resources into threatening and killing each other, rather than devote our attention to alleviating the pain that blights the lives of millions of people in their disease-soaked existences.